Okay. Keep reading. Kirchhoff laws. Kirchhoff laws. See, Kirchhoff laws say you can find any circuit का current voltage at any point of time है. इस branch में चाहिए current, इस branch में voltage you can find by using Kirchhoff laws. Okay. So Kirchhoff is the name of the person. He is having two laws. He has given two laws. So first law and second law. So we will see एक एक का. Second law is most and most important. ज़्यादा questions will be coming. First law will be simple. Okay. Kirchhoff first law or Kirchhoff current law. We call it as KCL, short form है KCL, Kirchhoff current law. And we also called it is junction rule. Junction rule बोलते हैं. So any circuit by using this one we have to solve KCL का. देखो what is the statement says? At any junction, the sum of the current entering the junction is equal to sum of the current leaving the junction. Okay. Junction means, what is the meaning of junction first? When three or more wires meet, that is called junction. Like suppose says there, suppose which is junction? This is junction. Where they go 1, 2, 3 wires are meet. This is junction. And where the two wires meet, that is called node. That is called node. Two wires meet, that is called node. Okay. Three or more wires meet, that is called junction. At any junction, the sum of the current entering the junction is equal to sum of the current leaving the junction. So that is simple. Dekho, suppose I am taking I1, I2, I3, I4. So this is junction, right? Where three or more wires meet. So now we apply KCL at the junction. Always we are applying KCL at the junction. So incoming currents are what? Junction ke upar, which is incoming? I1 is incoming, I3 is incoming, I2 is incoming. So I1 plus I2 plus I3, sum of the incoming currents is equal to sum of the currents leaving the junction. Leaving the junction wala I4. Right? And if I bring this side, I1 plus I2 plus I3 minus I4 is equal to 0. I can call sigma is sum of currents is equal to 0 at the junction. So we represent sometimes KCL को ऐसे represent करेंगे. Sigma at the junction I is 0. So sum of the currents, like if incoming को we can take as positive, outgoing को we take as negative. So उनका सभी का sum is always 0. This one we already know, right? Normally, देखो, suppose 2 ampere, 3 ampere. So how much current is flowing at the junction, out of the junction? दोनों मिलके? 5 ampere. So sum of the current incoming is equal to sum of the currents outgoing current. This is our KCL. तो जंक्शन पर अप्लाई करो, ऑलवेज सॉल्व करने वाला क्वेश्चंस फुल. ओके. नाउ दिस कॉपीड. Now this law is based on conservation of charge. Okay. Amount of charge entering per unit time. See, sum of the current entering the junction is equal to sum of the current leaving the junction, right? Current is nothing but rate of flow of charge. So amount of charge entering the junction is equal to the amount of charge leaving the junction per unit time. So this is based on conservation of charge. So dq by dt incoming is equal to dq by dt outgoing. This is nothing but conservation of charge. Okay. And here when you're applying, suppose मान लो the current I is equal to 3 ampere. If I tell I is equal to minus 3 ampere means how to represent? The current is going in the opposite direction, right? So 3 ampere means kabhi minus means indirectly we have to reverse the sign, reverse the arrow. Okay, current is flowing in this direction. Okay. Chalo. Now current KCL understood, right? Some of the current entering the junction is equal to some of the current outgoing junction. Numericals करेंगे इसके बेस में. So they'll give any circuit, something circuit they'll give. They'll tell to find current I2, I3, I6 and the given values. देखो branch currents are given. देखो I4, I5, I3, I6, I2, I1 is given to you. He is telling to find I2, I3, I6. Okay. First, what are the I1 is minus 0.3 ampere. What is the meaning of that one? I1 is they given the arrow. They only given the arrow. That is, he's telling minus 0.3. I can change the arrow and I can put 0.3 amperes instead of minus. I can remove minus. Arrow change karke I'm putting the 0.3. I4 is 0.8 ampere. I4 is 0.8 ampere. And I5 is 0.4 ampere. Right? Okay. Now we'll try to find junction. Dundo. Pilot. Junction is this one. This is junction. Now apply KCL. Sum of the incoming current is equal to sum of the outgoing currents, right? So that means junction mein, S junction mein I am applying KCL. So I4 is equal to I5 plus I3. Now I4 is how much? 0.8 is equal to I5 is 0.4 plus I3. So therefore I3 is equal to 0.8 minus 0.4 is 0.4 amperes. This is the current. Junction may try to apply some of the incoming current towards junction is equal to some of the outgoing current. You can able to identify it which is incoming, which is outgoing. Dot ka coming means wala incoming, jo dot se away wala outgoing, right? Now same way we got I3, you got right. Now try to apply I2 and I6. I2 and I6. A junction le lo. You take this A junction. This current is how much? I4 is given, right? This is I1, right? Apply junction में, R junction में apply करो and solve. R में apply करो. So what is R? Yeah, Satvik. What happened? Why late?
Sir, network issues.
You'll tell either only every time.
That's real.
बीच में आए तो what you will understand, Satvik. बीच में क्या आए तो what you will do all those things. So time first only जो daily you are seeing the same thing, not only this one. Last 10 minutes, 5 minutes compulsory. देखो I will note the next class में. देखता हूँ time पे आ रहा है. हाँ. R junction में apply करो. Tell me what is the answer?
1.1.
1.9.
1.
How much? 1.1. Okay. I6 is? I6 means कैसे लेंगे? कौन सा junction लेंगे? A junction लेंगे. With 3 or more wires meet. That is junction. Okay. So Q में लगाओ. Q में क्या है? Incoming currents is equal to, okay, incoming current out भी है. I6 plus I3 is the incoming currents and outgoing currents is I2. That's all.
.7.
No wrong. I2 is 1.1, right? 1.1. I3 you got as 0.4. So
1.5.
you're telling me I6 answer?
Yes, sir.
I6 wrong. This also we are missing. Dekho, I1 is also missing, right? I1 is like this, right? वो apply करो I1. This we missed here. So that is also incoming current, right? देखो, this is incoming, this is incoming, this is also incoming. So plus I1 is equal to outgoing current is I2. Now solve. Junction में sum of the incoming currents is equal to sum of the outgoing currents that use.
0.4.
Yes. So I6 is 0.4. and I3 I2 is 1.1 amperes, right? Chalo. Understood, right, Shivangi? So always junction find karo. Junction mein incoming currents is equal to outgoing currents. It can be 10 currents, it can be 20 currents. Anything incoming wala is equal to outgoing currents that use. Okay, that is KCL, Kirchhoff current law. First law साथ this. Okay. Now देखो कैसे solve करेंगे. 3 resistors are given, 2 ohm, 4 ohm, and 2 ohm, and switch is connected. When the switch is closed, initially switch is open, close kiya to, how much current is passing through it? He's telling how much current is passing through the switch. And this is the symbol for earthing. Earthing ka potential is how much? Potential is earthing ka
0.
0. Okay. Now these are point potential. ऐसा देगा they will give exam में. They will not give like complete circuit. ऐसा नहीं, ऐसा देगा point potentials. So it's telling to find current in this one. Okay. So मैं क्या करूँगा? Junction we identified this is a junction, right? उसको potential मान लो x. X is a potential of the junction. Okay. Current आप decide कर लो, direction आप decide कर लो. Because and apply always KCL. Okay. And apply KCL at junction में you can current direction ऐसे ले लो. So I can choose like this. I1. This is I2. And this is I3. Because incoming currents equal to outgoing currents. I can take like this also. I1, I2, I3 also I can take. But answer आने के बाद, if it is a negative, that means our direction is wrong. Magnitude same है, उल्टा आएगा बोल के आपको identify होगा. Okay. And now apply junction में. So junction में we are applying the Kirchhoff current law. So sum of the incoming currents I1 plus I2 is equal to outgoing current. Outgoing current is I3. Right? This is one. I1 plus I2 is equal to I3. Okay. Current will flow from higher to lower potential or lower to higher potential. Current flows from
Higher
current,
to lower.
higher to lower. Okay. So higher is 20, lower is X because of I1 direction. Because of I1 direction, this is higher, this is lower, right? So क्या होगा? See, how to find current? Current Ohm's law use करके potential difference upon resistance is nothing but current, right? Potential difference upon resistance. So tell me, I1 is how much? 20 minus X upon resistance is 2, right? Plus I2, tell me, I2 क्या आएगा? शिवंगी बोलो. I2 is how much? Current will flow from higher potential to lower potential. So one is X is potential, one is 5 volts is potential. Tell me.
5 minus x by 4.
X by 4 is equal to? Sadik bolo. Current is flowing from higher to lower. So this is 0, this is X. So current I3 will be potential difference upon resistance. So kitna?
2
X
minus x.
minus 0. Because higher to lower only current will flow. The arrow, we put arrow, right? So that means this is higher, this is lower. We are assuming. Okay. By how much? 2.
2.
Because potential difference upon resistance is nothing but current. Now solve for X. X आने के बाद X minus 0 by 2 is the I3 current. That only is asking.
So X is minus 9.
X is minus 9, huh?
Yeah.
9. Check करो.
Minus.
Minus 9.
Okay, 1 second. No.
Yeah.
I'm getting x is 9.
9. X is 9. देखो LCM 4 है. So 40 minus 2x plus 5 minus x is equal by 4 is equal to x by 2. So 2 to the 4. So 45 minus 3x is equal to x. So 5x is equal to 45. X equal 9 volts. Okay. Now current is how much? How to find I3 current? You're asking this one, right? The current passing through it in the switch. How to find current? You know this potential, you know this potential, you know resistance. Find current.
9 by 2 for
Hmm.
I3.
9 by
2 for
2.
I3.
4.5 current is there. Okay. So I3 is equal to 9 by 2. 4.5 amperes. So point potential, they will not give like closed circuit. वो हम लोग को we have a habitude of having battery current ऐसा है, but ऐसा नहीं, point potentials बोलते हैं. Okay. साथी का understanding है थोड़ा? Yes. Next. Solve करो. Find the current through 12 ohm resistors. इसमें current चाहिए. Okay. So ये भी point potential से we by seeing only we can understand it. Okay, KCL apply करेंगे बोल के. Okay. So junction identify कर, this is junction where 3 or more wires meet. देखो 1 2 3 4 meets the junction. Junction का potential is x मान. And current decide कर लो, आप decide कर लो. Current I and apply KCL is equal to I1, इधर जाएगा I2, इधर जाएगा I3. Now I चाहिए for us. Okay. Now junction में if I apply KCL, what is the KCL says? Sum of the current entering the junction is equal to sum of the current outgoing junction, I1 plus I2 plus I3. Now apply potential difference by resistance and solve and tell the answer. So current का direction देखकर only you can decide which is higher, which is lower potential. फ्रैक्शन में आएगा, फ्रैक्शन का आंसर बोलो.
7 by 12.
Yes, correct. 7 आया 7. आया 7. Yes, 7. So this is a KCL का base में. Understood it? Sum of the incoming currents equal to outgoing currents. Okay. Next, very famous one, which is Kirchhoff's second law. Kirchhoff's second law is also called as Kirchhoff voltage law, which is KVL, short form KVL, Kirchhoff voltage law, or loop rule बोलते हैं. Loop rule. तो इसका कैसा क्या है देखेंगे. Okay, KVL loop rule. So what is the statement says? The algebraic sum of the change in potential around any closed loop is 0. The algebraic potential around a closed loop, that means sigma of delta V is 0 for a closed loop. Okay, closed loop में potential difference is 0. Closed loop means wherever you are started, again come back to the same point, उसका potential difference is always 0. Okay. So we can tell simple small example के through we can understand. So this is suppose one branch is there, one loop A, B, C, D. So I am starting from here, and again I will come back to the same point A. I want to calculate the potential difference. Okay, I am starting from here. Again, want to come back to the same point. Okay, so देखो, what is the potential difference when you come from here to here? VB minus VB minus VA. Now when you come from B to C, what is the potential difference? Tell me. VC minus VB. And when you come from here to here, when you come from here to here, what is the potential difference? Final minus initial, right? So VD minus VC. And again, when you come from here to here, what is the potential difference? VA minus VD, right? Potential difference. So देखो, minus VA plus VA minus VD plus VD minus VB plus VC, VC minus VC equal 0. So closed loop में potential difference is always 0. Closed loop में. This is a statement of the KVL. And KVL का it is based on conservation of energy, law of conservation of energy. Okay ना? चलो. It is based on law of conservation of energy. First one is conservation of charge. Sometimes theoretical question also they will ask. Dash which law is based on conservation of charge? Means KCL. Conservation of energy is KVL. Energy can neither be created nor destroyed. Total loop का sum is 0 always. Okay. Now steps to apply KVL. तो short form में लिखो steps का क्या करना है देखो. So identify the loops. First step क्या है? Simply identify the loops. Yeah, just write the headings. Identify the loop. मतलब loop you can identify, right? How many loops are there suppose in the circuit में? Tell me how many loops are there? One loop and two loop. Right? This one loop, one loop. Two loops are there. Right? First identify the loops. Next one. Assume directions of current. So first step क्या है आपको? Current को each branch में current you have to put. Okay. As per the battery, they will give batteries, resistance, everything. You have to put the current I1 and apply KCL always. When you're putting the current, when you're distributing the current, always apply KCL and put the current. Okay. Assign the direction of current in each branch. Each branch में either clockwise or anti-clockwise, any direction में branch current you will apply. Suppose they'll give a circuit like this. Suppose this is a circuit they given. So your battery is given. You will put the current. I current is coming. इधर जाएगा I1, इधर जाएगा I2. ऐसा we have to put the current. Okay. Next, if assumption का tension नहीं ले, assumption wrong है तो the current value is just negative आएगा. Okay. So answer आने के बाद they will tell which direction the current. Sometimes JEE mains में they will ask this type of question. 1 minute. Okay. So Anushri वाला. Next step. Closed loop and transversal direction. Okay. आप branch current तो दे दिया. Now whether you have to go to the clockwise or anti-clockwise, we have to decide. Whether you have to go clockwise or anti-clockwise, we have to decide. Okay. Any direction, the answer will be same. And we have to apply the sign conventions. देखो sign conventions. Sign conventions क्या है? ये पूरा numericals में समझ में आ जाएगा. देखो suppose battery is there, cell is there, इसका EMF VC plus minus. I am choosing a path. Path means you have to walk. Path means you have to walk like this. Tick 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 बोल के you have to walk. Okay. Now see, when you are going from, when you're walking from here to here, you are going from higher to lower, lower to higher potential. Higher to lower. Higher to lower means what is the potential difference will be? Minus E. Higher to lower जा रहे ना, that's why you have to put, देखो plus to minus when you're going minus ही आएगा. अगर when you're going from minus to plus, so what is the potential difference at time? Path like this, when you're walking from here to here, what is the potential difference? Will lower to higher you are going, right? Delta V is plus C, right? Next, coming to resistor, a battery की कहानी है. Now coming to resistors. Resistor means you have to understand this one. देखो, This is a resistor. The current you will decide, right? I current will be deciding. And path is like this. Suppose path is you're writing. Okay. Path means you're walking from here to here. Okay. Here you have to understand when current and path are in the same direction, potential difference you should take as minus IR. Because resistance में IR is a drop, right? IR minus IR लेने का. Okay. Now in the resistance में suppose current is flowing like this and path you are taking like this. Suppose ऐसा situation है तो क्या करेंगे? Delta V will be current and path are in the opposite direction. We have to take plus IR. This only. देखो against current plus IR and along the current minus IR. ये sign conventions you have to follow. Okay. ये पूरा क्वेश्चंस करने समय इजी हो जाएगा. Okay, done. So small question लेके we will solve the कैसा करेंगे we'll see. Done. Okay. चलो. Then we have to apply KVL. KVL क्या है? Del sigma of delta V is 0. That's it. Okay. Now we are doing the numerical. We will follow step by step and solve करेंगे. Just write the KVL equation and apply delta V is equal to 0. Okay. Now we'll see the numerical through. ये कुछ बैठ नहीं करने का, just method है. That's it. चलो. Find the current through each of the following, like 2 ohms and 1 ohm using KVL. देखो सिंपल सर्क्यूट लिया. Why? Because आपको आंसर सेम आने के लिए डायरेक्टली बोल सकते हो करंट कितना है. टेल में दिस इज अ सीरीज सर्क्यूट, 2 रेसिस्टर्स आर इन सीरीज. करंट फाइंड करो. 2 amperes because 6/3, right? 2 amperes. Okay. Now by using KVL we have to use. Okay. First step is what? Battery से current निकालो. Current you have to generate. Okay. So one battery is I generated current. Okay. इस ब्रांच में करंट आएगा I, इस ब्रांच में करंट I जाएगा, इस ब्रांच में करंट I जाएगा एंड इस ब्रांच में करंट आएगा. So one thing understand is एक ब्रांच में एक ही करंट रहने का. One branch में one current only should be there, and whatever the current coming from the battery, the same current should flow to the battery. So इधर I लेके फिर से घूम के आने के बाद I1 नहीं आने का. Whatever the current generated by the battery, the same current should flow in the battery only. Okay. So branch में देखो each branch में आपको आ गया first step current को generate करने का. Second step में आप लूप चूज करो, कौन सा लूप जा रहा है. ओके. वेदर यू हैव टू यू वांट टू गो क्लॉकवाइज एंटी क्लॉकवाइज आपको डिसाइड करने का. ठीक है. वन लूप ओनली इज देयर, प्रॉब्लम नहीं है. आपको क्लॉकवाइज एंटी क्लॉक योर विश. ठीक है. वी आर गोइंग क्लॉकवाइज, मतलब वी डिसाइडेड टू गो क्लॉकवाइज डायरेक्शन. क्लॉकवाइज डायरेक्शन वी डिसाइडेड मींस वी हैव टू वॉक फ्रॉम देयर टू अगेन कम बैक टू द सेम पोजीशन. ओके. समझ में आने वाला. clockwise means we have to here start किया तो again come back to the same place clockwise जा रहा है. So we decide path, right? So path का मैं इधर diagram ड्रा कर रहा हूँ. This is the path I have to walk. 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 In this में we have to follow. So एक बार fix करने के बाद again we should not change. थोड़ा बोर लग रहा है बोल के again I go reverse बोल के नहीं जाने का, right? हाँ. Now third step. So first step क्या है? Currents को. Second step को which direction you have to go we have to understand. Third step. Apply the KVL. What is the KVL says? Sigma delta V in a closed loop is 0. This is a statement, right? Closed loop is 0. This is KVL. Okay. Now start. Tell me. You are walking from here to here. You are going from minus to plus, right? Lower to higher. So we have to take plus 6 or minus 6. You are walking from here.
Plus 6.
Plus 6. So 6. Okay. इधर आया इसमें कुछ भी रेजिस्टेंस नहीं है. You went. Now here walking, the path and current are in the same direction. We should took plus IR or minus IR? Minus IR. So minus I is I only, R is 2 ohms. Okay. So again walking, you are walking like this. Again current and path are in the same direction. Again minus I into 1 ohm. Again came back to the same position, right? Because already we finished equal 0. So 6 is equal to 3i and I is equal to 2 amperes. Khatam. So ये सिंपल सर्क्यूट है, बट आगे 2-3 लूप्स आएगा, दैट टाइम प्रॉब्लम हो जाएगा. सो अंडरस्टैंड ईच एंड एवरी स्टेप में. अंडरस्टूड. चलो कब बेटा सत्य अंडरस्टूड नो करो. फाइंड द करंट आई इन सर्क्यूट. देखो दो बैटरीज आर गिवन, दो सेल्स आर गिवन टू यू, रेजिस्टेंस आर देयर. ओके विच डायरेक्शन में हम लोग लेंगे करंट? इधर से लेंगे और इधर से लेंगे. बैटरी जनरल कॉमन सेंस यूज करेंगे. किधर से जनरेट करेंगे? अकॉर्डिंग टू योर फीलिंग सेइंग दैट
From 9
9
volts.
volts. बड़ा ना, बड़ा ब्रदर को भी have to give थोड़ा देने का, राइट? सो बिगर बैटरी से करंट इज कमिंग. देखो ए ब्रांच में आई हो गया, ए ब्रांच में आई हो गया, ए ब्रांच में आई हो गया, राइट? एंड इस ब्रांच में आई हो गया. एंड देखो वॉट एवर द करंट जनरेटेड, दैट सेम करंट विल फ्लोइंग इन द बैटरी. Now you take clockwise, anti-clockwise, your wish. Wherever you want to go. Okay. Which one will take? Clockwise, anti-clockwise in this way. Any direction. So you want to take anti-clockwise or clockwise? ठीक है. Clockwise you want to go. Anti-clockwise कुछ भी डायरेक्शन गया तो भी अगर आंसर रॉन्ग है तो that means उल्टा बोल के that's it. कुछ नहीं. Okay. Now you are going clockwise direction. So path डिसाइड करेंगे. इधर से path ऐसे जा रहा हूँ. Path ऐसा, path ऐसा, path ऐसा. Now third step क्या है? Apply sigma of delta V is equal to 0 in a closed loop. Now solve. Apply with sign conventions. थोड़ा माइनस प्लस का आंसर रॉन्ग हो जाएगा. रेजिस्टेंस में सेम डायरेक्शन माइनस, ऑपोजिट डायरेक्शन प्लस. बैटरी तो सिंपल है, बैटरी तो लोअर टू हायर गया तो प्लस आएगा, हायर टू लोअर तो माइनस आएगा. ओल रेजिस्टेंस सेम डायरेक्शन माइनस लगाने का. कितना?
1.
1. यस. आया सब लोग को? ओके. नेक्स्ट. ना 2 लूप्स जाएंगे. 2 लूप्स में करना है. ये इसी एग्जाम्स में देगा दे विल गिव. ओके. नाउ व्हाट इज सेइंग? फाइंड द करंट थ्रू ब्रांच बीडी. बीडी में ब्रांच में करंट चाहिए. इधर दोनों बैटरी में आपको सेल्स में, दोनों सेल्स में आपको 30 वोल्ट 30 वोल्ट दे दिया, राइट? सेम. सो इधर से मुझे करंट चाहिए. सो आपको फर्स्ट स्टेप क्या है? वी हैव टू पुट द करंट्स फ्रॉम द बैटरीज. ओके. आई कैन टेक एनी करंट बट ऑलवेज केसीएल यूज करेंगे. ऐसा नहीं कि ऑल आर इनकमिंग गए तो प्रॉब्लम हो जाएगा, आउटगोइंग नहीं रहेगा तो. ओके. सो देखेंगे. इसमें I1 लगाओ. ओके. इसमें I2 लगा रहा हूँ. ओके. सो इस ब्रांच में I1 आएगा, इस ब्रांच में I2 आएगा. दोनों मिलके क्या होगा? अप्लाई केसीएल. इट विल बी और इनकमिंग करंट इक्वल आउटगोइंग करंट, राइट? सो यू कैन टेक एनीथिंग, I3 और I1 प्लस I2, राइट? लेस नंबर ऑफ वेरिएबल्स लेंगे ऑलवेज. इट विल बी गुड बिकॉज 2 वेरिएबल्स है तो 2 इक्वेशंस चाहिए आपको. 3 लेके आए तो अगेन 3 लेके आना पड़ेगा. ओके. इधर कितना करंट जाएगा? टेल में. I1 plus I2 is coming. इधर कितना जाएगा?
I2.
I2. I told right. What are the current? बैटरी से जनरेट हुआ, सेम करंट शुड फ्लो. इसमें I1. तो फर्स्ट स्टेप हो गया. एंड चेक करो ईच ब्रांच में एक ही करंट है, दो दो करंट नहीं आ रहे. तो एक एक बार इधर भी लगाएगा इधर भी लगाएगा, प्रॉब्लम हो जाएगा कौन सा करंट लेंगे बोल के. ओके. नो सेकंड में चूज करो लूप्स का क्लॉकवाइज है एंटी क्लॉकवाइज है, वेयर यू वांट टू गो. सो आई एम गोइंग क्लॉकवाइज. इधर भी क्लॉकवाइज जाएंगे. सो फर्स्ट लूप, सेकंड लूप. ओके. सो पाथ भी डिसाइड कर दिया. नाउ ड्रॉ द पाथ सो दैट आई विल नॉट गेट कंफ्यूज. सो लाइक दिस गोइंग, ऐसे जा रहा हूँ, ऐसे वॉकिंग कर रहा हूँ, ऐसे कर रहा हूँ फर्स्ट लूप में. इधर भी ऐसे जा रहा हूँ, ऐसे जा रहा हूँ, ऐसे जा रहा हूँ, ऐसे आ रहा हूँ. ओके. फर्स्ट लूप आई एम टेकिंग लूप 1. लूप 1 में आई अप्लाई सिग्मा ऑफ डेल्टा v इज इक्वल 0. दिस इज ओनली KVL राइट एट द क्लोज लूप में. नो अप्लाई. इक्वेशन बोलो, फिर से मिस्टेक हो गया तो प्रॉब्लम हो जाएगा. एक एक इक्वेशन को, फर्स्ट इक्वेशन आने के बाद बोलो फर्स्ट लूप को. टेक कॉमन, सिंप्लीफाई एंड टेल द इक्वेशन.
So first equation is 10 is equal to 3I1 plus I2.
3I1 plus I2. Very good. First one. Same equation got first one. Doing karo.
I'm getting 10 is equal to 3I2 plus I1.
3I2 plus I1. Apply karo. From here you are going again. Come back to original. Tell me. इधर क्या होगा? We are going from here to here. Minus to plus you are going. Lower to higher you are going. So it is plus 30.
Yeah.
Okay. Now here current and path are in the same direction. Same direction में minus लेने का, right? So minus उस branch का current कितना है? I1 times R is 6. Right? Here also current and path are in the same direction. Minus कौन सा? I1 plus I2 times 3 is equal to 0. ये माइनस एक लिया तो रॉन्ग हो तो रॉन्ग हो जाएगा. हाँ. नो कितना होगा? 30 minus 6I1 minus 3I1 minus 3I2 equal 0. So 30 minus 9I1 minus 3I2 equal 0. 3 से डिवाइड कर लो. So 10 minus 3I1 minus I2 equal 0. So therefore 10 is equal to 3I1 plus I2. First equation. तो सेकंड विल अप्लाई करो. प्रॉपर में माइनस प्लस में टेढ़ा नहीं आने का.
Sir, second equation is 2I2 plus I1 is equal to 10.
Yes.
I1 is equal to 2, I2 is equal to 4.
Oh, okay, okay. Now what is the current in the BD branch means?
I1 plus I2,
I1 plus
which
I2
is
करो.
6.
Yes, correct. प्रतीक आपको क्या है? 6. आया? Showing is what is the second equation?
10 is equal to 2I2 plus I1.
2I2 plus I1. Yes. Now solve.
I1 is 2 and I2 is 4.
Yes. So now JEE मेंस क्वेश्चन करेंगे, so आपको करके सॉल्व करके आंसर बोलने का. देखो, in circuit shown below, the current in the resistor 1 ohm is, in the current in the resistor is 1 ohm. Direction I दिया 1 ohm is. So you only decide the direction. Whatever things I'll give options. Try to do. 0. Oh. Very precisely he asked the question. Current आने के बाद also, whether the current is flowing from P to Q or Q to P are also he asking. Satvik, you what Satvik? Getting it? करो करो. वही same thing, same method solve करो. You got Shivangi? करो.
So is it B?
D या B या?
B from Q to P.
ये वाला?
Yeah.
Okay. आपको शिवांगी? मिस हो गया? This answer very good. मेंस में मेरे को मेंस क्वेश्चन अच्छा कर रहा है, क्या टेंशन नहीं, इतना टेंशन लगता है. ओके देखो, सो करंट यू कैन पुट, एक ही बैटरी है ना, दो बैटरी है बट बड़ा बैटरी से कर रहे हैं वाला, राइट. सो करंट आई विल प्रोड्यूस आई. सो इसमें I1 जाएगा, इसमें I2 जाएगा, राइट. तो इसमें I1, इसमें भी I1. ओके करंट आएगा, इसमें अगेन विल गो दोनों I1 plus I2, right? I current only, right? So what is I? I का what is the I is nothing but I1 plus I2. You can use this one, right? I is equal to I1 plus I2. Okay. Now you are going clockwise and anti-clockwise. चलो एक anti-clockwise जाएंगे, ये वाला भी anti-clockwise जाएंगे. Okay, path is decided, right? हाँ. Now apply करो like this, like this, like this. Now tell me शिवांगी, you start from here. इधर से आ जाओ, अगेन सेम पॉइंट में पी तक आ जाओ. ओके टेल मी फ्रॉम हियर टू हियर अप्लाई केवीएल. यू आर गोइंग फ्रॉम माइनस टू प्लस, राइट. सो प्लस 6 minus 6?
-6.
No, lower to higher you are going. You are walking from here to here. Lower to higher means potential is cell का is +6. साइन कन्वेंशन you have to know. बैटरी में लोअर टू हायर गया तो प्लस लगाने का, हायर टू लोअर मीन्स माइनस लगाने का. बट रेजिस्टेंस में करंट एंड पाथ दोनों चेक करना पड़ेगा. करंट एंड पाथ आर इन सेम डायरेक्शन -IR, करंट एंड पाथ इन ऑपोजिट डायरेक्शन +IR. ओके नेक्स्ट टेल में, इसमें कुछ नहीं है. अगेन इसमें देखो करंट एंड पाथ आर इन द सेम डायरेक्शन में माइनस, टेल में
-3 I1.
I1 into 3, right? IR. Okay. Yeah. If you see here, current and path are in opposite direction. क्या लगाऊं? ऑपोजिट में प्लस आएगा ना रेजिस्टेंस में, प्लस I2 इंटू कितना 1, दैट्स इट, इक्वल 0. क्या हाँ कितना होगा? सो 6 minus 3I1 प्लस I2 इक्वल 0. फर्स्ट इक्वेशन, ठीक है. तो सेकंड का बोलो. यू आर गोइंग एंटी क्लॉकवाइज डायरेक्शन. ओके नाउ अप्लाई करो. यू आर गोइंग फ्रॉम माइनस टू प्लस. यू शुड टेक प्लस लेना, माइनस लेना. बोलो शिवांगी. इधर से वॉकिंग कर रहा हूँ, मतलब ऐसा 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 ऐसा. चल में
+9.
+9 बोलो, कंटिन्यूस बोलो. नेक्स्ट
plus 9 minus 2I2.
Minus 2i to I current is coming, right?
Oh, I right, minus 2I.
2i. Okay. Here the current and path are in the same direction, right?
Right, so minus I2, 1 into
Into
I,
1, right?
right.
Next, current and
And
path are in the same direction.
minus 3I1 plus I2, which is I,
3i is equal to 0.
right?
So 9 minus 5i. I के जगह में I am substituting i1 plus i2 minus i2 is equal to 0. So कितना होगा 9 minus 5i1 minus 5i2 minus i2 is minus 6i2 equal to 0. Put only 5i1 5i2 minus 6i2 equal to 0. नो ये दोनों को इक्वेशन को सॉल्व करने का, ये दोनों इक्वेशन को वी हैव टू सॉल्व. 2 वेरिएबल्स 2 इक्वेशंस. यू नो एलिमिनेशन मेथड, राइट? एलिमिनेशन मेथड, सब्स्टिट्यूशन मेथड. सॉल्व किया तो यू विल गेट i2 as 0.13. सो इन दिस केस में आई गॉट पॉजिटिव नेगेटिव आएगा ना, माइनस आएगा ना. हाँ, माइनस आएगा. i2 विल बी 0.13 आएगा आफ्टर सॉल्विंग. दैट मीन्स व्हाट इज आवर अजम्पशन इज रॉन्ग, राइट? सो करंट इज गोइंग इन द ऑपोजिट डायरेक्शन, मतलब Q to P जाने का. देखो Q to P जाएगा. इतना प्रिसाइसली कॉन्सेप्ट वाइज में देगा वो लोग जेईई मेंस में. दैट्स व्हाई आपको कॉन्सेप्ट नीटली लर्न करने का, डू मेनी क्वेश्चंस, देन ओनली यू विल अंडरस्टैंड ऑल थिंग्स. ओके, सो नेक्स्ट क्लास में we'll do 1 or 2 more questions in the Kirchhoff laws, and then we'll go for series, cells and parallel. Okay, any doubts? All right, chalo, right.